I'm about to teach you a mathematical proof that could have gotten you killed in ancient Greece. A rational number is a number that can be expressed as a over b, where a and b are two mutually prime integers, so they don't share any factors among each other than 1. The Greeks thought that all numbers were rational. This is really interesting because we actually find that there are many irrational numbers just from doing some very basic geometry. For example, if I have a right triangle with two legs, each 1 unit long, then I can do some basic Pythagorean theorem and find that the hypotenuse is square root 2 units long. Nowadays, we know that the square root of 2 is irrational. It cannot be expressed as a over b, where a and b are both integers. What this also means is that its decimal expression just goes on forever without ever repeating itself. My question as a kid was always, maybe it does repeat itself, but it takes a billion digits to do so, so we just don't know. But there's actually a way to prove that it's irrational. Let's be Greeks for a second and think that some x when squared equals 2, and that x is rational. Then if x squared equals 2 and x is rational, it can also be expressed as a over b. So a squared over b squared equals 2. We can then go ahead and multiply both sides by b squared. So now we have a squared equals 2b squared. There are now 4 possibilities. Either both are even, both are odd, one is odd, one is even, or one is even and one is odd. We can immediately remove the possibility that both of them are even, since we want them to be mutually prime anyways. And we can also eliminate anything that will leave one side even and one side odd. Since 2b squared must be even, since it's being multiplied by 2, then both of them being odd, or a being odd and b being even, since a squared is odd as long as a is odd, those possibilities are also out the window. Now, this is the complicated one. Let's assume that a is even and b is odd. If we have a squared on one side and then 2b squared on the other, both are even, maybe they could be equal, but they can't, because the prime factorization of a, being an even number, means that it has a 2 in its prime factorization. And since it's being squared now, that means there are two 2's. So it is a multiple of 4. Since an odd number squared is odd, then b squared is odd. You're just tacking a 2 on the end of it. So it's a multiple of 2, but not a multiple of 4. A number that's a multiple of 4 can't be equal to another number that's not a multiple of 4. It doesn't make any sense. Therefore, our initial assumption must have been incorrect, and x is irrational. And there you have it. We just proved that the square root of 2 is irrational, and that irrational numbers can exist. This was so antithetical to the Greeks that the first guy to prove this was thrown down a river, never to be seen again. Yeah.